Yeah. Good evening, children. Good evening, online
Good evening,
students.
ma'am.
Yeah. Good
evening,
evening. Good evening, children. I've shared my screen. Visible?
Yes, ma'am. Yes, ma'am.
All right. So when we started this chapter, quadrilaterals, we understood the definition of the term polygon. So a polygon is a closed figure made up of line segments. Okay, a polygon is a closed figure made up of line segments, right, children?
Yes,
So
ma'am.
yeah, next class we'll talk about curves. So then we'll just modify the definition of a polygon. A polygon is a simple closed curve. A polygon is a simple closed curve made up of line segments. Nothing. So we have some, like we have something, called curve, open curve, closed curve. Very simple. So we'll do this in the next class. Okay, all this we'll do in the next class. Yeah. All right, children. So you know what a triangle is. I don't have to introduce you to a triangle, quadrilateral, pentagon, and all this. Just go through the slide. So 3 sides. It's called a triangle. And 4 sides quadrilateral, 5 sides pentagon, 6 sides hexagon, 7 sides heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon, n sides n-gon. So if a polygon has 100 sides, it's called you can just write it as 100 and hyphen gun. 100 gun. N-gun meaning whatever is the number of sides. So if the polygon has 51 sides, 51 gun. All right. Okay. A polygon with n sides. A polygon with n sides is called n-gun meaning. So if it has 35 sides, 35 gun. All right. Okay. So there's nothing to make a note here, children. You're aware of this. We'll see this in the next class. Yeah. Now look at this one. How many diagonals? How many diagonals does a polygon with n sides have? So we have an expression or we have a formula to calculate the number of diagonals a polygon can have. We have a formula to calculate the number of diagonals a polygon can have. And it's given by n into n minus 3 by 2. N into n minus 3 by 2 is the formula or is the expression to find the number of diagonals a polygon has. All right, now we know that a quadrilateral has 2 diagonals, right? A quadrilateral, it has 2 diagonals, 2 diagonals. All right, so how do you find that using this formula? N is 4 because n stands for the number of sides. In this formula, n stands for the number of sides. All right, yeah, so 4 into 4 minus 3 divided by 2. So 4 into 1 by 2, 4 by 2, 2, 4 by 2, 2. Now, supposing a decagon, 10 sides. So the number of diagonals in a decagon is 10 into 10 minus 3 divided by 2, which is 10 into 7 by 2. 2 ones are 2 5s are 35. A decagon has 35 diagonals. Okay. Now, there's another thing. Into how many triangles can you divide a polygon? Into how many triangles can you divide a polygon? See, these are 2 different things. What we just saw is the formula to find the number of diagonals a polygon can have. And that's given by the formula n into n minus 3 by 2, where n is the number of sides the polygon has. Now, next what we are about to discuss is into how many triangles can you divide a polygon? All right. I think you can just make a note of this, children. Please make a note of this. Whatever you see in this slide.
Ma'am, did the figures given here?
Yeah. Yes. Leave your bags down. Keep it on the. Now, the third figure, KLMN, is a concave quadrilateral. The third figure, KLMN, is a concave quadrilateral. I'll tell you now, you must be writing. I'll not disturb you. We'll talk about the third figure, this one. Yeah. What are you doing? No, but I want you to draw the diagrams also. Okay, done, children?
Ma'am, just one more minute. Not yet.
Okay. All right. Yeah, children. So now, when we talk about polygons, we have two types, concave and convex polygons. All right. We have concave. Don't write this. I have it in the next slide. Don't write this now. So when we talk about polygons, we have two kinds of polygons, concave polygon and convex polygon. Okay, concave polygon and convex polygon. Now, what is a concave polygon? A concave polygon is one in which at least one interior angle is a reflex angle. If in a polygon, at least one interior angle is a reflex angle, then that polygon is a concave polygon. Convex polygons is what we normally see. Every interior angle will be less than 180 degrees. Convex polygon. A convex polygon is a polygon in which all the interior angles will measure less than 180 degrees. If all the interior angles of a polygon measure less than 180 degrees, it's a convex polygon. If at least one angle measures more than 180, that is, if it's a reflex angle, more than 180 is a reflex angle. More than 180 but less than 360 is a reflex angle. So if at least one angle measures more than 180, that is, if it is a reflex angle, then the polygon is a concave polygon. Yeah. And so in figure 3, you see a concave quadrilateral. See, there's a quadrilateral. In figure 3, K, L, M, and like this. This one is a quadrilateral. K, L, M, N is a quadrilateral. And what? How do you draw the diagonals? You join two non-consecutive vertices. You won't join the next. When you join the consecutive vertices, it's a side. When you join the consecutive vertices, if you join A to B, B to C, C to D, then they are the sides of the polygon. Supposing the polygon is A, B, C, D, E. A, B, C, D, E. If you join A to B, B to C, C to D, and so on. So when you connect the consecutive vertices, they are the sides. If you join the non-consecutive vertices, you get the diagonal. That is, you choose one vertex, leave the next one, then the next one, non-consecutive. Okay, so see here, which are the, so now this one is a quadrilateral. K, L, M, N is a quadrilateral because you can see it has 4 vertices and 4 sides. It is a quadrilateral and it's a concave quadrilateral because this angle M measures more than 180 degrees. This angle M measures more than 180 degrees. The interior angle, not the angle outside, the interior angle should measure more than 180. So you can see that this interior angle measures more than 180 degrees. So it's a concave polygon. And talking about the diagonals, see the quadrilateral is KLMN. Join K to M. It's a diagonal. And join L to N. It's a diagonal. So this one is not to be mistaken for a triangle. This is not a triangle. You can see the diagonals and dotted lines. KM and LN in dotted lines representing the diagonals of the concave quadrilateral KLMN. Do it again. KLMN is a concave quadrilateral. So KLMN. When you join the non-consecutive vertices, this and this and this and this, KM diagonal. This is the diagonal. This is one diagonal, and then LN. So here the diagonal lies outside the quadrilateral. So in this concave quadrilateral, this diagonal lies outside the figure. That's a diagonal. LN is a diagonal. All right. Am I clear, children? Online students?
Yes, ma'am.
Very good. Yeah. So that's about this. Remember the formula to find the number of diagonals a polygon can have, n into n minus 3 by 2. Okay. So a polygon in which each angle is less than, every angle should be less than 180. A polygon in which each angle is less than 180 degrees is a convex polygon. A polygon in which at least one angle is more than 180 degrees or a reflex angle. That's what I mentioned. More than 180 is a reflex angle. Okay, it's called a concave polygon. So you can see some figures here. All these are convex. These are concave. So you can see that, that opening, that mouth-like opening. Such things are concave. You can see the mouth-like opening. You can just see this one concave, as if an animal is opening its mouth, like the mouth of a cave, concave. You just have to visualize it like that. It doesn't exactly look like that. You visualize it like that. It's like as if something is kept its mouth wide open. So like a cave. A cave has an open mouth, right? A cave. It has an open mouth. Yeah, like that it is. See this? It's like as if you can enter the cave like this. 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 So it's very obvious, when you look at the figure, you can say whether it is concave or convex. You don't have to actually measure any angle there. Just by the face of the figure, just look at the figure and you can say, yeah, this is convex. Yeah, concave, 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 convex, concave. And look at these. They don't have a mouth like this. These figures here, they don't look like as if they've kept their mouth open. See here? So such figures are concave polygons, while the others here are convex polygons. Yeah, quickly make a note of this. Convex polygon, concave polygon. Write down. Yeah, rough figure. You don't have to use this, just rough figure. Finished? Yeah.
Ma'am, just a second, ma'am.
Yeah, okay.
Done, ma'am.
Yeah. Done, children? Online students finished?
Yes, ma'am. Yeah, ma'am.
Okay. We'll complete that later. Sorry? Yeah, just leave that space. Now coming to regular and irregular polygon. Okay, regular and irregular polygon. So a regular polygon is one in which all the sides are equal and all the interior angles are also equal. A regular polygon is one in which all the sides are equal and all the interior angles are also equal. See, when you take a quadrilateral, it has 4 sides and also 4 interior angles. So the number of sides and the number of interior angles of a polygon is the same. A polygon has as many angles as the number of sides. A polygon has as many angles as the number of sides. If it has 10 sides, it has 10 interior angles and 10 exterior angles also. Okay, so a polygon in which all the sides are equal as well as all the interior angles are equal is called a regular polygon. Otherwise, it's irregular. Now, tell me a triangle which is a regular polygon. Name the triangle that's a regular polygon. Yeah, I got the answer here from a student here. Equilateral triangle is a regular polygon.
Equilateral.
Correct. Equilateral triangle is a regular polygon because in an equilateral triangle, all the 3 sides are equal and each angle measures 60 degrees. So an equilateral triangle is a regular polygon. Now, among quadrilaterals, which one is a regular polygon? Among quadrilaterals, which is a regular polygon?
Square.
Square. Square because in a square, all the sides are equal and all the angles measure 90 degrees. Angles are not equal. In a rhombus, all sides are equal. The angles are not equal. So the definition of a regular polygon is the sides and the angles. All the sides must be equal and all the interior angles also must be equal. So a square is a regular polygon because all the 4 sides are equal and each angle measures 90 degrees. All right. Okay. So if a pentagon, if in a pentagon, all the sides are equal. See, when we say pentagon, it has 5 sides. The 5 sides may be of different lengths. When we just say pentagon, it is a 5-sided polygon. That's all. A pentagon is a 5-sided polygon. Now, these 5 sides may be of different lengths. But when you say regular pentagon, then it means all the 5 sides are equal and the 5 interior angles are also equal. All right, children? Yeah. Please write down this. Diagrams, children, just leave some space for that. I'll share the picture on WhatsApp. You can complete it later. Leave some space. Just take the theory now. Write the definition of a regular polygon. Leave some space below. You can complete the diagrams later, and then irregular polygon, some space below for the diagrams. Done writing, children?
Yes, ma'am.
Okay. Finished? Yeah.
Ma'am, should we draw this in our note?
No. So this is self-explanatory, the figure here. So you can see the interior angle is marked and the corresponding exterior angle. You can see the interior angle here and the corresponding exterior angle, correct? Interior angle, the corresponding exterior angle. Now, what we need to understand is, look at this figure. Now, these angles, now this one is 1, 2, 3, 4, 5, a pentagon. This one is a pentagon. Now, you can see the exterior angles in blue, green, orange, yellow, and whatever color here. I don't know, red maybe. So red, orange, yellow, blue, and green. You can see the 5 exterior angles of the pentagon. We won't call it a regular pentagon. No, it's a pentagon. We don't know if it's a regular pentagon, and it doesn't look like a regular pentagon also. So now this, so the pentagon has 5 sides, 5 interior angles, and 5 exterior angles. You can see them here. The angles in red, blue, green, yellow, and orange are exterior angles. Now, when you cut those pieces and put them together, they'll form a complete angle. See, when you cut those angles, and put them together, that's what you see here. You can see the angles here: red, blue, green, yellow, and orange. When you put them together, an angle has 2 arms, right? An angle has 2 arms. So when you cut those V's, the V's, like this V and this V and this V and this V and this V kind of shape, I'm saying, and put it together, it'll form a complete angle. So that means this is true for any, not only for a pentagon, this is true for any polygon. So we say that the sum of all the exterior angles of a polygon is always 360 degrees. The sum of all the exterior angles of any polygon, whether it's a triangle, quadrilateral, pentagon, whatever, hexagon, heptagon, whatever, the sum of all the exterior angles will always be 360 degrees. The sum of the interior angles will be different. We've already seen that. In a triangle, the sum of the 3 interior angles is 180 degrees. But in a quadrilateral, the sum of the 4 interior angles is equal to 360 degrees. In a triangle, sum of all the 3 interior angles is 180. In a quadrilateral, 360. So the sum of all the interior angles in a polygon will keep increasing with the increase in the number of sides. More sides, the sum of the interior angles will be more. Less sides, it's less. And the least sum is 180. 180 is the least sum. And from there, it will keep increasing. 180, then 360, 540, it will keep increasing. Okay. So, understood what we discussed, children? The sum of all the interior angles will be different. But in any polygon, the sum of all the exterior angles is always 360 degrees. So that's what we're trying to take away from this figure.
Ma'am?
Yes.
So you're trying to say that the interior angles the degrees may change, but the exterior angle will, okay. But the exterior angles would never change. They'll constantly be in 360.
Correct. In any polygon, even if it has 100 sides, the sum of all its 100 exterior angles will total to 360 degrees only. I repeat, even if the polygon has 100 sides or more than that also. Okay, so even if a polygon has 100 sides, so it will have 100 interior angles and 100 exterior angles. The sum of the 100 interior angles can be calculated, but will be large. But the sum of all the 100 exterior angles will be exactly 360 degrees only. All right?
Okay, ma'am. Got it now. Thank you.
All right. So now the thing is, we've understood that, 1 second, I'll just take an extra slide. Okay. So now we understand that the sum of all the exterior angles of any polygon is 360 degrees only. So now we are concerned about the sum of all the interior angles of a polygon. Okay. So how do you find the sum? Now look at this. Let's consider a hexagon. Now see, I cannot easily draw a decagon. I have the figures that show you. Now I can draw a hexagon. 1, 2, 3, 4, 5, 6. This one is a hexagon. It's a polygon with 6 sides. It's not a regular hexagon. It's not a regular hexagon. Now, I choose, now you can see there are 6 vertices. 1, 2, 3, 4, 5, 6 vertices. 6 sides, 6 vertices. Now you choose any one vertex. Choose any one vertex. I'll just take this one because it's right on top. You can choose any vertex. Now from this vertex, connect the non-consecutive vertices. Connect from this vertex, connect this vertex to the other non-consecutive vertices. So from here like this, then from here. So this way, we are able to divide the hexagon into 1, 2, 3, 4 triangles. We are able to divide the hexagon into 4 triangles. See, you should not cross over. Now, don't say, why did you not draw like this? No, see, you should not cross over like this. See, when you put the 4 triangles together, you should get the hexagon. So for that, this is sufficient. That's why I said choose any one vertex, and from that vertex alone, draw line segments joining the other non-consecutive vertices. So when you do that, you're able to divide the hexagon into 4 triangles. The sum of the 3 angles is 180 here. The sum of the 3 angles is 180 here, 180 here, 180 here. That is, see, this angle plus this angle plus this angle is 180. Then this angle plus this angle plus this angle is 180. Now this angle plus this angle plus this angle is 180. And finally this angle plus this angle plus this angle is 180. So like that, see, we have marked all the 6 angles of the hexagon. So the sum of all the 6 angles is equal to 180 into 4, 720 degrees. So now the hexagon has 6 sides, and we are able to divide the hexagon into 6 minus 2, 4 triangles. 2 less than the number of sides. Hexagon has 6 sides, and we are able to divide the hexagon into 4 triangles. So what's the relation? What's the connection between 6 and 4? So 4 is 2 less than 6. So if the polygon has n sides, you can divide it into n minus 2 triangles. You can try. I'll show the other figures. Now see a quadrilateral. When you take a quadrilateral, choose any vertex, and from there connect it to the other non-consecutive vertices. Only this you can do. If you do this, you're overlapping. That's the diagonal. That is the diagonal. But we are not trying to draw all the diagonals. We are not attempting to draw all the diagonals. No. We are only trying to divide the given polygon into some number of triangles. Once that is achieved, we'll stop. These are diagonals. When you do this, these are diagonals, but we're not trying to connect all the diagonals. Now, these are diagonals. This is a diagonal. This is a diagonal. This one is also a diagonal. But we are not trying to connect all the diagonals. We're not trying to connect all the diagonals. So like this, using these diagonals, we're able to divide the hexagon into 4 triangles. Stop. That is when we put the triangles together, we get the figure, the complete figure. Okay. So now this quadrilateral, choose any vertex, and when you connect it like this, see, you've already divided into 2 triangles. When you connect this diagonal, you have already divided the quadrilateral into two triangles. So what's the sum here? 180. Here 180. 180 plus 180, 360. So here the sum of this angle, and this angle is 180. The sum of this angle, and this angle is 180. So that makes all the four angles 1, 2, 3, 4 angles. So the sum of all the four angles of a quadrilateral is equal to 180 plus 180, 360 degrees. And here also you see that the quadrilateral has four sides, and we are able to divide it into 4 minus 2, two triangles, 1, 2 triangles, four sides, and number of triangles is 4 minus 2, two triangles. A pentagon, see it? 1, 2, 3, 4, 5, pentagon. Choose any vertex. Choose any vertex. Join, join. 1, 2, 3 triangles. How many sides? 5 sides. How many triangles formed? 5 minus 2, 3 triangles. If the polygon has n sides, then you can divide it into n minus 2 triangles. So the sum of all the angles in a pentagon will be 180 plus 180 plus 180, 540 degrees. So the sum of all the interior angles, of a pentagon is 540 degrees, of a hexagon is 720 degrees. So what we should have understood is that we can divide any polygon into some number of triangles. You can divide any polygon into some number of triangles, and the number of triangles formed will be equal to the number of sides of the polygon minus 2. 2 less than the number of sides of the polygon. So if the polygon has 10 sides, you can make 10 minus 2, 8 triangles. So the angle sum property will be 8 into 180. Because one triangle 180 degrees. 8 triangles will be 8 into 180. If there's one triangle, the sum of the angles is 180 degrees. If there are 5 triangles, one triangle 180 degrees, 5 triangles, 5 into 180, 900 degrees. All right. So that's the formula. That's the formula to find the sum of all the interior angles of any polygon. The formula is n minus 2 into 180 degrees. N minus 2 into 180 degrees. So if the polygon has 10 sides, then 10 minus 2, 8 triangles are formed into 180. Into 180, because for one triangle, the sum is 180 degrees. So for 8 triangles, 8 into 180. So this is the formula. N minus 2 into 180 degrees is the formula to find the sum of all the interior angles of any polygon. Write down, children. And exterior angles we already know is 360. Okay, one more thing, I'll finish. Exterior angles we already know is 360. Now, if it is a regular polygon, then each interior angle will be, and each exterior angle will be by n, because n is the number of sides and n is also the number of angles. Number of sides, number of angles will be the same. If a polygon has 5 sides, it has 5 angles. So that if it's a regular polygon, the total measure will be divided between 5 angles. See here, n minus 2 into 180 degrees is the sum of all the interior angles of any polygon. If this polygon happens to be a regular polygon, then yeah, all the angles will have the same measure. That means this total will be divided equally between all the angles, right? So if the polygon has 7 sides, it'll have 7 angles. So divide by 7 or n, number of sides. So this n minus 2 into 180 by n. will give us the measure of each interior angle in a regular polygon. N minus 2 into 180 degrees divided by n. Because if there are n sides, there are n angles also. So divide by n. All the angles will divide the total measure equally. So this one represents the measure of each interior angle of a regular polygon. Now each exterior angle will be 360 by n. Each exterior angle will be 360 by n. Because for any polygon, the sum of all the exterior angles is 360 degrees. So each exterior angle will be 360 by n. Each interior angle will be n minus 2 into 180. This is the total by n. Yeah, make a note of this, children. Finish writing, students, online students?
Just a second, ma'am, on the last line.
Okay, okay.
Done writing, ma'am.
Done, all of you? Okay. So
Yes.
here you, yeah. So we see two things here, all about the interior and exterior angles of a convex polygon of n sides. And here about a convex regular polygon of n sides. Only in a regular polygon you can find each interior angle and exterior angle. If you want, see, if you have to find each exterior angle, then it should be a regular polygon. This formula, see, you can see here, only where it is regular. That means all the sides, all the interior angles, all the exterior angles are equal. Only here you will have this formula, each exterior angle, 360 by n. Each interior angle, n minus 2 by 180 by n. All right? Okay. We haven't finished. 1 second, I'll just tell you something. See here. So this is the interior angle. And this is the corresponding exterior angle. So you understand that the sum of the interior and the exterior angle is 180 degrees. That we understand, right? Each interior angle, not okay. Interior angle plus exterior angle is equal to 180. Is that correct? Interior angle plus exterior angle is equal to 180. Okay. All right. Now we'll just try to write without saying. So now first we're talking about a convex polygon of n sides that we know, n sides. Okay. Convex polygon. Next is about a convex regular polygon. So what is the sum of all the angles? What is, listen to hear my question and then answer. So what is the sum, or what is the formula to find the sum of all the interior angles of a convex polygon? What's the formula? How many triangles will be there? N minus 2 triangles into 180 degrees. So this is the sum of all the interior angles of a polygon. Yes or no, children? Now, 180 can also be written as 2 into 90. Is that correct? 180 degrees is 2 into 90. Now, when you multiply this 2 inside, you will get 2n, multiply the 2 inside, 2n minus 4 into 90. 2n minus 4 into 90. So you can also say that the sum of all the, interior angles of a polygon is equal to 2n minus 4 right angles. 2n minus 4 right angles. Sometimes MCQs, you will know it is this, but if this option is not given and this is given, So you should be able to identify that, right? N minus 2 into 180. 180 can be written as 2 into 90. Multiply the 2 within the terms in the bracket. So you get 2n minus 4 into 90, which is also called 2n minus 4 right angles. 2n minus 4 right angles. Because 90 degrees is the right angle. Where n is the number of sides. N is the number of sides or number of angles. It's all the same. What about the sum of all the exterior angles? 360 degrees. And what's the other thing? Each interior angle plus each exterior angle is equal to 180 degrees. So like if one of the interior angles measures 130 degrees, supposing, then the exterior angle will be 50 degrees. Now talking about the regular polygon. Now talking about the regular polygon. Okay, so n minus 2 into 180 degrees, or also 2n minus 4 into 90, both are the same. Each angle will be by n. Each interior angle by n. Each interior angle by n. Each exterior angle 360 degrees by n. Each exterior angle is 360 by n. Each interior angle will be n minus 2 into 180 by n or 2n minus 4 into 90 by n. Both are the same. Both will give you the same answer. Both are the same. You can use this. This you can use. This I just introduced so that you don't go wrong if you have one of these options in the MCQs. And here also each interior angle plus each exterior angle is equal to 180 degrees. That's what you have written down. So you can check it now. Just read it. As I keep reading it in your mind. And here, regular polygon, sum is 360. Each will be 360 by n. Okay, or each exterior angle you can also find like this because the total is 180. So you can also find each exterior angle like this, 180 minus each interior angle. Because the sum of these two is 180. So if you want to find each exterior angle, it will be 180 minus each interior angle. Interior angle sum is this one or this one. Each interior angle will be this one by n or this one by n. Or you can also find each interior angle like this, 180 degrees minus each exterior angle. Each exterior angle is 180 minus each interior angle. Each interior angle is 180 minus each exterior angle. So you can just don't make a note of all this, but you can just see here. So here you can see two triangles, quadrilateral divided into two triangles, pentagon divided into three triangles. So here it is 180 into 2 because two triangles. So 180 into 2, 360. Here three triangles. So 180 into 3, 540. Angle sum property. 1, 2, 3, 4 triangles. So 180 into 4, 720 degrees. 1, 2, 3, 4, 5 triangles. So 180 into 5, 900. 1, 2, 3, 4, 5, 6 triangles. So 180 into 6, 1080 degrees. So the sum of all the interior angles of an octagon, whether it is regular or irregular, the sum will be the same. The sum is the same for a regular or an irregular octagon. Octagon is 1080. Whether it is regular or irregular, the sum is the same. All right. Nonagon. 1, 2, 3, 4, 5, 6, 7. So you can see 9 sides. So 9 minus 2, 7 triangles. You can see a nonagon has 9 sides, but it can be divided into 9 minus 2, only 7 triangles. And 7 into 180, 1260 is the sum of all the interior angles. Because in one triangle, the sum of all the angles is 180 degrees. In one triangle, the sum of all the angles is 180 degrees. So in 7 triangles, 7 into 180. No. Shall I tell you again? You got it? Sorry? Yeah. The sum of all the angles in one triangle. Okay. The sum of all the angles in this triangle is 180 degrees, right? In this triangle, 180 degrees. So in all the 7 triangles, 1, 2, 3, 4, 5, 6, 7 triangles are there. In this triangle, the sum of all the angles is 180. So in all these 7 triangles, the sum of all the angles will be 7 into 180. One triangle, 180 degrees. Like one book, 180 rupees. 7 books, 7 into 180. So one triangle, 180 degrees. 7 triangles, 7 into 180. 1260 degrees. Yeah, so that's what it is. So decagon has 10 sides. So you can see 8 triangles here. So 8 into 180, 1440. Goes on with this. Children, I'm presenting a different presentation. Can you see the, not you, online students? Can you read my screen? Find the measure of each exterior angle of a regular pentagon. Yes or no? Yeah, take
Yes,
the
ma'am.
measure. Yeah. Please mark all this. Sorry, this is the answer. You don't want the answer? Okay, fine, fine. Okay. Okay. Okay, present it like this. Each exterior angle is equal to, please present it like this. Just do one for you. Yeah, I wanted to present the answer like this. Yes, I'm just giving you one example, so you can work the others based on this example. So what's the first line? That's the formula. Each exterior angle of a regular polygon is 360 by n. Now this one is a pentagon, so it'll be 360 by 5. Yeah. So 2 steps for every answer. These 2 steps for every answer. Let's come back in 5 minutes, children. Please complete this.
Done, ma'am.
Ready? Done? So pentagon, how many sides? Pentagon. 5. Hexagon? 6. Heptagon? 7. Decagon? 10. And then 15. Six. Pentagon is 5. Hexagon is 6. Heptagon is 7. Decagon is 10. Finish, children?
Yes, ma'am.
Okay.
Ma'am, the
So-
last minute.
Okay.
Done, ma'am.
Okay. All right. Please check your answers. Pentagon 72 degrees, hexagon 60, 51, 3 by 7, 36, and 24. Got this? Online students, all of you got this?
Yeah, ma'am.
Yes, ma'am.
Okay.
Yes,
You
ma'am.
need to write, you need to write these 2 lines, children, for every answer. First, each exterior angle of a regular polygon is equal to 360 by n. And then this one. The first one is a regular pentagon, then regular hexagon. So it'll be 360 by 5, 360 by 6. I have just written the formula once here. But you need to write this for every answer. Got it? Why for the last 2 you have not written the formula? Last 3. Just go for the first 2. Why did you divide 360 by 10? 0 and 0 gets cancelled. Third one, yeah, mixed fraction. Oh, yeah, 0.3. No, it's 0.4, not 3. Be 51.4. Goes on, but it'll be 51.4, not 3. Very good. See, he's written the formula for everything. Very good. You also had written. Yeah. No problem. For the exam, you must write the formula and then. Online students, can we go to the next one?
Yes, ma'am.
Yeah.
Ma'am.
Okay. Is it possible to have a regular polygon, each of whose exterior angles is 50 degrees? Okay. 1 minute. Let's just understand this together and then you can work it. So what is given? Each exterior angle is equal to 50 degrees. Each exterior angle is equal to 50 degrees. Now, what's the formula to find each exterior angle of a regular polygon? Exterior angle, so 360 degrees by n. 360 by n. Each exterior angle of a regular polygon is 360 by n. And that is given to be 50, right? That is equal to 50. So cross multiply 50, n is equal to 360. So n is equal to 360 divided by 50. 0 and 0 gets cancelled. So n is equal to 5 7 are 35.2. 7.2. Is it possible to have a polygon with 7.2 sides? N is what? What is n? N stands for the number of sides or number of interior angles. Okay, can you have 7.2 sides? No. So the answer
No,
is
ma'am.
yeah, it's not possible. So the answer to this question is no, it is not possible to have a regular polygon whose exterior angle, whose each exterior angle is equal to 50 degrees. It's not possible. Because if it were possible, then the answer for n will be a natural number. It will be something like 10, 11, 12, 13. It will be a natural number. You should not get a negative value or a decimal value like this. Correct? Done it in two ways. You can. The other method is, see, this actually is a little, like elaborate. So you don't have to do this. Just understand this method. All right. You can make a note of this if this is not wrong. This is correct. But it's slightly elaborate. Just do this method. I'll tell you how I've done the other one. You work this one first.
So we have to write everything on the screen, even the elaborating part, right?
I'll explain that and then you can make a note of it. I'll explain that first.
Okay.
Done? Yeah. Okay, we'll understand the alternate method. So now if if each exterior angle,
Can you just go to that slide for a moment? I was in the last line. Yes, ma'am.
if each exterior angle is 50 degrees, then what will be the measure of each interior angle? If each exterior angle is 50 degrees, what will be the measure of each interior angle? 180 minus 50, right? 180 minus 50, 130 degrees, yes or no? If each exterior angle is 50 degrees, then interior angle will be 180 minus 50, 130 degrees. Now, what is the formula to find the measure of each interior angle? N minus 2 into 180 by N is equal to 130. This is the formula to find the measure of each interior angle. N minus 2 into 180 by N. And that's equal to 130. Equate this. So you get, when you multiply 180N minus 360, 180 into N is 180N, minus 360 is equal to cross multiply 130N. So bringing the N terms on one side, 180N minus 130N is equal to 360. 50N is equal to 360. N is equal to 360 by 50. N is equal to 7, 1 by 5. Correct? So it's not possible. Because it should be a natural number. The number of sides should be 3 or anything more than 3. Even if it's 2, you cannot accept it because number of sides cannot be 2. Two-sided polygon, no. So minimum answer should be 3. So 7, 1 by 5. You understand? I don't have to explain more than this. Yeah. So you can also do it like this, children. See, n minus 2 into 180 divided by n is a formula to find the measure of each interior angle of a regular polygon. And this is equal to 130 degrees. So we multiply 180 into n, 180n, 180 into 2 minus 360, cross multiply is equal to 130n. Then gathering the n terms on one side, having the n terms on one side and taking the number to the other side. So 50n is equal to 360 and yeah, n is equal to 360 by 50, which is 7, 1 by 5. So yeah, now you can take down this one, children. Done? Completed, children? Online?
Yes, ma'am.
Yeah. Yeah. So find the measure of each interior angle of a regular polygon having 10 sides. What's the formula? (180). N minus 2 into 180 by n. Yeah. And n is 10. Yeah. Got this? And for the second one, I'll just do the correction, the first one itself. Okay, so the second one will be with 15 sides. No, you should not multiply. Did you multiply 13 and 180? No, you should cancel. 5 3s are 5. 5 3s are 15. And then 5 6 are 30. Then 3 1s are 3 12 times. Yeah, 13 12 times is 154. 156. Understood, children?
Yeah.
Okay. Any questions? Yeah. Yeah, try this. Yeah. Anyone online can answer this with the steps? Yarani? Shreya? Aishwarya? Gayatri? Lakshana? Who else is there? Saujanya? Harsha? Yeah, one of you answer this? Okay. So what is this 100 degrees? What is 100 degrees? It is, yeah, each interior angle. Each interior angle. But what's the formula to find each interior angle? N minus 2 into 180 by N. This is given to be 100. Each interior angle of a regular polygon is given by N minus 2 into 180 degrees divided by N. Okay, so here it is given to be 100 degrees. I'll just correct this 1 second. 1 second. We'll present it like this, children. Each interior angle of below this, we'll write the formula. So each interior angle, the formula is N minus 2 into 180 degrees divided by N, and that's given to be 100. So cross multiply and also multiply within the bracket. So 180n minus 360 is equal to 100n. So 180n minus 100n is equal to 360. 80n. 80n is equal to 360. N is equal to 360 divided by 80. So n is equal to 0 cancels, 4 9s are 4 2s are 9 by 2, which is 4.5. So it's not possible. Therefore, it is not possible. Yeah. What is 100 degrees? It is each interior angle. Each interior angle. So you start like that. Each interior angle is equal to 100 degrees. Now below that, what's the formula to find? N minus 2 into 180 by n. And that is given to be 100. That's equal to 100. Yeah. No, which part you don't understand, Shivam? I'll tell you. This one, huh? The next step. Oh, you already worked it, is it? No. Here, no. N is not 100. 1 minute. Come here, I'll check this. This is find the measure of each interior angle. The sides are given to you here. 10 sides. And you should find the angle. There, this N is 10. N is 10. Here, the angle is given. N is not 100. The angle, this angle is equal to 100 degrees. This answer is this answer is equal to 100 degrees. N is not 100. Each interior angle is 100. N is not 100. You substituted there. See, what is N? No, N is the number of sides. N is the number of sides. Here, number of sides is given 10, 15. Number of sides is given. So we substitute there. Now here, what is given is this is the angle. What is this n minus 2 into 180 by n? That's the angle. And that is equal to 100 degrees. You should equate this formula to 100. The value of n will be the number of sides, which is not given here. You should not put this degree for n here. Finished? Strike it on and do it. Yeah. N is not 100, children. Number of sides is not given. N is not 100. 100 degrees is the measure of each interior angle is 100. So below that, the formula. Each interior angle formula, n minus 2 into 180 by n, that is equal to 100. Finished? Yeah. See whether it is a regular or an irregular pentagon. The sum of all the interior angles is the same. The sum of all the interior angles, even if it's a regular pentagon, the sum is n minus 2 into 180. So hexagon, how many sides? 6. Nonagon, 9 sides. Nonagon, 9 sides. Pentagon, 5 sides. Yeah. Yeah, so what's the sum of all the angles of a hexagon? How much? 720. Nonagon? 1260. And a polygon with 12 sides? 5,000? 1,008. 800. Don't see the alternate solution. This is enough. Look at this one. So this is the formula. And yeah, 540, 720, 1,260 and 1,800. Online students got these answers?
Yeah.
Yes, ma'am.
Okay. Can we go to the next one, children? Writing here. Finish. You finished. You? Yeah. Yeah. This is the next one. What is the number of diagonals in a heptagon, octagon? What's the formula to find the number of diagonals? What's the formula to find the number of diagonals in a polygon? N into n minus 3 by 2. N into n minus 3 by 2. Yeah, do this, children. So 12 sides will be 12 into 12 minus 3 by 2. Yeah, hello. Done, children? Online students?
Not yet. I'm in the last one.
Okay, yeah. So what is the value of n we substitute? N is the number of sides or the number of angles. Done, all of you? Finished, online students?
Yes, ma'am.
Okay. Okay, online students, use the emoji, raise your hand. Yeah, if you're finished, thank you. You can leave. Somebody come to take you, right? You can wait till your mom's come. Bye. Yeah. So I can see Shreya, Aishwarya, Gayatri, Yarni, Asha, Lakshana. Saujanya, you're not there. Okay, so Shreya, Aishwarya, Gayatri, Yarni, Harsha, Lakshana. Very good, children. All right, children, online students, that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am.
Good night, children. Thank you.
Ma'am, you said you will explain me the long division method, the photo I've sent.
Oh, you did not remind me at the beginning of the session, Aishwarya. I told you, no?
Oh, I thought the end of the session, ma'am.
No. I said just remind me at the beginning of the session so that I can tell the class.
Okay, ma'am. So should we do it in the next class?
Yeah, please. Yes. Beginning
Yes,
of the session, I said. Yeah.
Okay,
So that
ma'am.
the class will, so that I can also share that with the class.
Okay, ma'am. I'll remind you in the beginning of the class.
Sorry. Yeah. Okay. Good night. Thank you.
Thank you, ma'am. Bye.
Bye.